This is your key for your dilations homework. You are to dilate this image with a scale factor of 1/2, 1.5, and 2, which means you're going to have to do this 3 times. So let's write down our pre-image coordinates. R is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 9. 6, 7, 8, 9, 2, 9. S is 8, 9. T is 8, 4. U is 2, 2. Okay, first you're going to dilate with a scale factor of 1/2. Whenever you dilate with the scale factor, you multiply all coordinates by that scale factor. So, if the scale factor is 1/2, you multiply everything by 1/2, or 0.5, because it's the same thing. 0.5 and 1/2 are the same thing. So, I got that question 3 times today. Not sure why. If you know it's the same thing, then you can use it. Alright, so 1/2 of 2 is 1, 1/2 of 9 is 4.5, 1/2 of 8 is 4, 1/2 of 9 is 4.5. If you can't do this, if you can't do your halves quickly, then you need to be actually multiplying by 0.5 or 1/2, top times top, bottom times bottom. What I mean is, put your whole numbers over 1 and go straight across. 1/2 of 8 is 4, 1/2 of 4 is 2, 1/2 of 2 is 1, 1/2 of 2 is 1. Plot your points. By the way, this is now the R prime. These coordinates are R prime, S prime, your figure. You got to make sure that you put that down. 1, 4.5. 1, 2, 3, 4.5. 4. 1, 2, 3, 4. 4.5. 4. 1, 2, 3, 4. Up to 1 over 1. Now let's notate something here. In the notes, I said, if you multiply by a scale factor of more than 1, what happens to the image? It blows up, it enlarges, it gets bigger. When you multiply by a scale factor of something like, 1/2, less than 1, what happens to the image? It shrinks. So this is a really good first visual for you, this homework here. Now, we are going to multiply with a scale factor of 1.5. So, let's start with our original coordinates. RSTU, 2, 9, 8, 9. T is 8, 4. U is 2, 2. Now, new scale factor, new piece of work. 2 times 1.5, 1.5. They're the same thing. 8 times 1.5, 9 times 1.5. 8 times 1.5, 4 times 1.5, 2 times 1.5, 2 times 1.5. Now, 2 times 1.5 is 3, 9 times 1.5 is 13.5, 1.5 times 8 is 6, this one is 13.5. Here's how I'm doing this quickly, in case you want the trick. A whole 2 is 2, and 1/2 of 2 is 1. Put them together, that makes 3. A whole of 9 is 9. 1/2 of 9 is 4.5. Add them together, you get 13.5. So that's the little trick there. This is 6. This is not 6. This is 12. This is 6. This is 3, and this is 3. Plot your points. 3, 1, 2, 3, up 13.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.5. Now go over 6. 1, 2, 3, 4, 5, 6, and go up to 13.5. Oh, wait a second. I made the same mistake here. This is 12. So up 12, or over 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up 13.5. I knew there was a mistake because it's an enlargement. 12, 6. Over 12, up 6. 1, 2, 3, 4, 5, 6. Over 3, 1, 2, 3, up 3. 1, 2, 3. Connect your dots, and you can see when you multiply by more than 1, you have a scale factor of more than 1, like 1 and a half. It enlarges. My lines aren't straight, but you've got it. Now, you have another scale factor to multiply by. I'm going to separate my work here. R, S, T, U. R is 2, 9. S is 8, 9. T is 8, 4. U is 2, 2. You have a new scale factor of 2. So let's do that. 2 times 2, 9 times 2, 8 times 2, 9 times 2, 8 times 2, 4 times 2, 2 times 2, 2 times 2, and get your new coordinates. 4, 18, 16, 18, 16, 8, 4, and 4. I'm not going to plot this on my graph because I do not have enough room. My Snagit image is a lot smaller than your image. But you do have enough room on yours, so you do need to plot the new coordinates for scale factor of 2, which means we doubled the image. The only thing left on this is your little sentence down at the bottom. If one polygon is a dilated image of another polygon, then you had to use some inferencing. So you need to go back to your notes and look at the top part. It said dilations. The figures will become similar. Anytime you dilate a polygon, those figures are similar. So, if one polygon is a dilated image of another polygon, then the polygons are similar.